Hello and welcome to part 5 of QED Stata 2. The next part here, S12, is fairly straightforward. It's just a repeat of the previous part. So you literally can just copy exactly the same lines from the do file. So copy these lines here, paste them in below and then adjust them. I've already adjusted them. So change them from H2 to H3 and so on. So I've called it HHU15, meaning the household under 15s. I've asked for detailed statistics and I've asked for a frequency thing with the normal distribution on that as well. So it's going to do all that at once. So here's the details. So it's got some positive skewness indicated here. Mean about 2.15. No problems here. And I've lost the actual graph. So similarly, this seems that this is a slight positive skew as well. But otherwise, that's fairly straightforward. Now the same analysis for the next scale variable, which is remittances in H65. So let's do the usual cheat of just I'll copy this across. So first one's adjusted so it looks like that. And then the next two lines like this. So I've called it remits for remittances. You can call it something different. Get the detailed statistics, draw a histogram with frequencies and the normal curve added. So I'll do all those three things. And I get some really weird results. I mean, look at that. So that's the chart for remittances. So I hope you've drawn that and seen that. So most people have got like way less than 200,000. I can't remember what the unit of currency is, but someone's got this, about 20 or so households got an enormous amount coming in for remittances, which is really odd. So what's happening there? Yeah, that's really odd. Looks like there's some people related to someone very rich. What's really happening is you can get a clue from the printout here, which is the top few numbers of this mad number here. And in fact, if you read the documentation from the people that carry the study out, these numbers are not real numbers. These just represent where people said, oh, I don't know. How much remittances are you getting? We don't know. We can't tell you. We're not sure about that. In that case, they just coded this really big number to show that that value was missing. Unfortunately, Stata doesn't recognise that as a missing value. The Stata has a different code. So that throws the analysis a bit. So the question is, before we answer that, why do you think the research, why didn't they just type in not known? Why did they type in a number instead of that? And if you're going to type in a number, why such a colossal number? So pause the video and think about that. So I hope you paused it and thought about it. That the reason they don't just enter not known is because they want to make sure that data all stays as numbers. If you have text in there, then it causes all kinds of problems when you try and process it, because you try and do calculations with it and you get a text coming up and it just creates an error. So they need a number so they can still carry on doing calculations. Why such a huge number? They have to make it such a huge number because it must be much bigger than any possible actual observation. Because if people are all having sort of actual values down around this area, like up to 10,000, 50,000 of it, if they use one of those values for the missing thing, the missing value will get confused with the data. So missing values should always be something that completely can never actually be realistic. So I can easily spot that it's not a real data item, which is what we didn't do here. So to cut a long story short then, if we want to actually work with this data, we've got to get rid of these numbers and make them into things which Stata realises is a missing value. We could just change everything into dots, but dot in Stata just means missing for no particular reason. It's good if we can actually give it a specific indication, so we can preserve the information about which ones are missing because people didn't know, which ones because they refused to say, and so on. So we can use A and B. So I was just thinking about A, this 999981. So this command here, it inserts. So I'll stick that into the do file as well. And that needs to go in after that. So after you've renamed it, then replace it with that, all these crazy numbers that are really big, and then you can redo. Once you've done that, redo the stats, redo the charts, and it should look a bit more sensible. Yeah, and that's an improvement. Now you can see it still is really skewed. There are some households that get like 5,000 or 50,000, but there's no one really who's getting like 100 million. That was just a silly number. But it is like so many things in the real world, it is heavily skewed, positively skewed. So nowhere near matches normal. And there's the figures for it. So we got rid of those high numbers now. Slightly more normal, far more realistic looking. Okay. Now do H66. So similar things with H66. And then the calculates. So again, another really weird situation. There's percentages. Someone's got nearly 100% comes from remittances. According to that, we can see here that it's just another one of these things where it's 98 and 99s. And in this case, 98 and 99 were used as the missing variables because obviously they thought they won't really get a number as big as that. So here 98 means don't know. 99 was when the person refused, didn't want to tell them, said no, I'm declining to tell you that. So they're slightly different things. So we need to code those. That suggests here how to code them. It doesn't, I suppose you've gone past that already. Oops. Yeah. So add lines into the do file to recode those as B and C. Then rerun it. So pause if you haven't done it. Hopefully you've already tried it. So it needs to do something like this. So I've changed the name to remprop, remittance proportion. I'm going to change that to missing value B if it's 98, missing value C if it's 99. That's got rid of all those values. Then I can rerun the commands, and hopefully I'll get a much better looking set of stats and histogram. Yeah, that's more like it. Oops. So less skewed things. Still positively skewed, but slightly more even. Now we got rid of the totally unrealistic values. Maybe best to do that next part in the next video rather than get this too long. So thanks for watching.